This is the full solution video for section 5.1, problem number 4. All right, so we have our cost function here. All right, but now we notice that there's two variables in the cost function, L and H. All right, and so we need to solve this volume function for L or H. It's easier to solve for H. So I'm going to solve for H. And when I do that, I take 900 divided by 3/4 L squared. All right, so now when I have 900 divided by 3/4 L squared, it would probably be easier to rewrite it instead of dividing by 3/4, multiply by 4/3. So 900 times 4/3, of course, is going to give us the value there. All right. And so 900 times 4/3. All right. So 9 times 4 is 36. So that'd be 3,600 divided by 3. So we get 1,200. All right. And then divided by L squared, right? So I can leave that as divided by L squared, or I could write it as 1,200 L to the negative second, depending on how I wanted to approach it. All right. So that means our cost function then is 3/4 L squared times 4. So obviously the 4's reduce. So just 3L squared. All right, so those 4's reduce. All right, so now here I have a 2 times 6 LH. So I have a plus 12 LH. So L times H, but remember H was 1,200 L to the negative second, or over L squared. Plus here I have a 2 times a 3/4, so that'd just be a 3/2. So I have a 3/2 L times H, which is the 1,200 over L squared. All right, and then times a 6 as well. I apologize for that. So times 6 here. So 3 times 6 is 18. Let's make that an 18, and an 18 halves is 9. All right. Then I have a plus 3/4 times 3, so 9/4 L squared. All right. So now, okay, I've got a 3L squared and a 9/4 L squared. So 3 would be, if I multiply by 4 over 4, so I have a 12/4 L squared plus a 9/4 L squared. So I have a 21/4 L squared. All right. Sorry, that's supposed to be 4. All right, so 21/4 L squared plus, now here, okay, I have an L and an L squared, right? So that's just going to be divided by L, and I have an L and an L squared, so that's just going to be divided by L. So really, when you think about it, I have a 12 times 1,200 over L plus a 9 times 1,200 over L, right? So when I do this, I get a 12 plus 9, a 21 times 1,200 over L, right? All right, and so now here I have my cost function, all right, and now I want to take the derivative, all right? So let's go ahead and take the derivative so that we can find where our minimum occurs. All right, so C prime equals, all right, so 21/4 times L squared, so that'd be 21/4 times 2L. All right. Plus, this one is really L to the negative first. So that's going to be negative 21 times 1,200 L to the negative second. All right. And so now I want to uh, set this equal to 0 and solve. All right. So remember, this is going to be a 42. All right. So I've got 42/4. Actually, these will just reduce. So 21 halves L, all right, and then minus, I have 21 times 1,200. I'm just going to leave that alone for right now, all right? And this is L to the negative second. All right, so now in order to solve this, I want to factor. Now, I can factor out a 21, right? And then I can factor out the lower power, so L to the negative second, all right? Which leaves me with 1/2 L to the what? Well, remember, this was L to the first, so I need to make this L cubed so that L to the negative second, so -2 plus 3 is 1. All right, and then I have a minus. Now I factored out the 21, so I have a 1,200 remaining. All right, and so now I'm going to set each equal to 0. All right, so 21 L to the negative second, that would just be over L squared equals 0. But remember, that can never equal 0. And then I have 1/2 L cubed minus 1,200 equals 0. All right. So now 21 over L squared, that can never equal 0. All right. But of course, L equals 0 makes C prime undefined. All right, but of course, we know that that is not going to be our answer because when we look at this original problem, okay, L can certainly not be 0, right? Because if L was 0, then this thing would be 0 wide by 0 deep and then by infinitely tall, basically. And so that is not our answer. All right. All right. So now here I'm going to add 1200. All right. And then multiply by 2. So L cubed equals 1200 times 2. So 2400. And so L is going to be the cube root of 2400. All right. Now, if you get that decimal. All right. Cube root of 2400. Sorry about that. I'm just doing the calculation. Cube root of 2400. All right, so that gives us about 13.389. So that's 13.389. All right, and so that should be where our minimum occurs. But now we do want to make sure that we double check this. All right, and so we do want to do a sign analysis. All right, and so relatively simple sign analysis. I've got my 13.389. All right, and then our factor really is just these two factors here. So 21 uh, L to the negative second, and then our 1/2 L cubed minus 1200. All right, and so we get a 0 here. Remember, 21 uh, L to the negative second was only undefined at 0, right? So we don't want to check any negatives. All right, but now if I plug in any positive number, obviously that thing is going to be positive, right? Because it's 21 divided by L squared. So we're squaring it, but of course we're plugging in positives. All right, and then here, let's say I pick something to the left. Well, if I pick something to the left, like 0, right, I get a negative number. Right. And then if I pick something to the right, like 14, obviously we could do this calculation. All right. But we're going to end up with a positive there. Right. And so that means our derivative changes from negative to positive, indicating that we have a maximum. Right. Or sorry, a minimum negative to positive, right? And so then we just want to go back and we want to double check our question. It says, what dimensions will minimize the cost? Well, L is approximately 13.89, right? 0.389. All right. The width, remember, would be 3/4 of that. So then we can just multiply that answer by 3/4. All right. Which is going to get us approximately 10.041. All right. And then our height, remember, is 1200 divided by uh, L squared, right? So I'm going to recalculate the cube root of 2400. All right, and then we're going to take 1200 divided by that answer squared. All right, and so that gets me a height of approximately 6.694. All right, and all of these would be in feet. All right, so that is problem number 4.